Hi folks, we're going to take a look at 4D from the Unit 6 assignment, part 2. So they're asking us to factor this polynomial here. And first thing I notice is that there's 4 terms. And there's two particular methods that we saw that involve grouping with 4 terms. Now one of them involved having a cube term, a squared term, exponent 1 term, and a constant term. And this doesn't fall in that category. So the other one we had was to group it so that you had a difference of squares. So the first thing I notice here is I have an x squared, okay? And this looks a lot like a trinomial, okay? In fact, it is trinomial if I look at the last 3 terms. However, if I want a difference of squares, the idea is to try to take this trinomial and write it as a perfect square. But if I'm going to have a difference here, I think the first thing I'm going to have to do is factor out a -1. Okay, and let's see what happens when I do that. When I factor out a -1, what am I left with? I'm left with y squared plus 2y plus 1. So I have a perfect square minus, and if this is a perfect square, then we'll be able to use difference of squares. And when we look at this, it is a perfect square. Hopefully you start to recognize some of these. Okay, this is y squared, this is 1 squared, and 2 times y times 1, 2y is that middle term. Okay, so this expression in the brackets can just be written as y plus 1 squared. And so now what I've managed to do is to write this expression here as a difference of squares. All right, and now I can just apply my rule for factoring a difference of squares. It's just the first plus the last times the first minus the last. So it's going to be x plus y plus 1, and then x minus y plus 1. All right, so there's my factorization. Now it's just a matter of simplifying. Now notice here how I put brackets. It wasn't really necessary in the first instance because I'm adding this binomial, but it's certainly necessary when I'm subtracting the binomial because I'm subtracting the whole binomial. So the trick is to always use the brackets so you don't forget for when it is important. Okay, so here when I'm adding this binomial, the plus will have no effect, so it's just going to be x plus y plus 1. But here, of course, when I'm subtracting this binomial, I have to distribute the -1 to each term. So this is going to be x minus y minus 1. Okay, without the brackets, you might have missed the -1. All right, so let's just recap here. So this is an example of using grouping to create a difference of squares. The difference with this problem here is that first we had to factor out the -1 so I could create an expression squared minus this trinomial, which turned out to be a perfect square. Okay, that's it for this one.